So, in this video, I would like to show you how to create 3D data or elevation data, 3D visualization based on elevation data we have obtained. So, what we've got here are the regularly spaced point data, elevation data from the area of Grand Canyon. So these data, as we can see down here, are in decimal degrees, and if we go right click, we go properties, we check source, then we see that these data are in WGS 1984. To be able of using some base maps that are delivered by Esri and are hidden here in add base map, I would like to transform the data to so-called Web Mercator as a coordinate system that is used by Esri and is a native coordinate system for all base maps available within ArcGIS. So at first I go to search tools. If the search toolbar isn't here, it's up there, search. On Control F, I choose tools and I select project. Here, project data management, sorry, not the help file, but project. In data management toolbox, we set input data of feature class, that's the Grand Canyon. It will automatically detect that my data are in WGS 1984. I define the output location for my data. Grand Canyon Web Mercator, yes, output coordinate system will be 1984 Web Mercator Oxalate Sphere. If it's not listed in your favorites, you have to search for it like this. You just type in Web Mercator and it should be located in projected world Mercator. Yeah, so here we go. We go OK, and now we wait till our data are projected, which shouldn't take a long time. And here we go, it's completed. So we click, just wait till it draws. So we open a new blank map. We add the Web Mercator data. And now we can see that we are in decimal degrees, but we are in meters. Now we can add base map. We can add imagery and see what will happen. So now these are our data, and this is the location of Grand Canyon that they are covering, okay? Or we can add, we can add another base map, topographic. So we can check out our type of base map. We just have to wait a little till it loads. There it comes. Yeah, and it's hidden here under World Imagery. So here we got a Grand Canyon as well. So now our task is to create a DEM, a digital elevation model out of these data. If you right click on data we check the attribute table. So we can see that here as column called grade code, in our case, is the elevation. It can be Z elevation or grade code in this case because I have converted these data from a grid, so it doesn't matter. So just to make more sense, I will rename the field to say elevation, so it's not confusing. Okay, elevation. Now there are several functions for data interpolation. They are in 3D Analyst Tools and raster interpolation. And here are different types of interpolation methods used to interpolate data to a continuous surface like grid or DEM. Make sure you check your customize extensions that 3D Analyst and Special Analyst is checked. Otherwise, these functions won't work. Well, this function topo to raster is a function that converts topographical data into a DEM. So here we define our input data, Grand Canyon. We know it's that type are point elevation, not contour line. Here you can see all the types that are supported, but mostly we'll work with point elevation or contour lines. Point elevation, and here we set that the grade code that we have removed to elevation, which isn't reflected here, but we choose grade code as the elevation, information. So next we do is we will define output. We call it Grand Canyon, like this, Grand Canyon DEM, let's say. Here we can define, let's say, what is the special resolution of the data. The points are 3 meters from each other, so we set a grid to 3 meters, and we hit OK. And the function starts interpolating. And when the interpolation finishes, we have here the elevation grid for our area of interest. So now we can compute something that is called shaded georelief. The shaded georelief, 3D Analyst Tools, raster, surface, and hillshade is a sun illuminated surface. So we put our DEM as the input. We set Grand Canyon shaded as output, and we just go hit OK. And here you may see our hill shaded georelief, which is pretty nice. There are other analysis we can have a look at, like aspect. So all the time we use the DEM. Aspect will compute the orientation towards different board sides, like north, east, south, west. So you can see how are the slopes oriented, or we can compute slope. So again, we use the DEM. Say Grand Canyon slope. Here we can choose if we use degrees or percentiles. It's up to you. Here we go. Here you can see what is the steepness of your elevation data. This These data may be used, for instance, for calculation of erosion and in some other case. So now when we are finished with this, we can switch it off and we will prepare some data for 3D visualization. As you can see, this satellite image is not of very high quality. So we just try to zoom in a little till the resolution rises. So still not good enough. So we zoom a little further, 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 even further, 1 to 50,000. Now you can see that it's much more detailed. So we just take this part and we just check if it's covered with our DEMs. So we do it like this. And we just keep in mind just to have the ridge here or the patch of the Grand Canyon for the visualization. And now we will export these data as a texture for the 3D model. So you go to File, Export Map. Just jump to our folder. Grand Canyon, texture. Choose JPEG, 300 dpi, and we have to take right world file. This is the georeferencing file that will put your image into coordinates. Click yes. Just wait till it exports. We can do the same with the topographical map. Grand Canyon texture, topo, let's say. Okay, that's it. So now we are ready to launch ArcScene 10.4, which is the 3D visualization tool for our GIS data. So, and here in our ArcScene, we will load our DEM. So you can see that it's flat because the software doesn't know if this is elevation data or just a map or some other type of derived surface. So we have to tell him that right-click base height. We say that this grid is floating on a custom surface on the DEM surface. So now you can see that is elevated, right? We can see the Grand Canyon in 3D, but this is lousy visualization, right? Only the elevation DEM. So we just disable it, we switch it off, and we can load the shaded. And we do the same. We say that it's floating on a custom surface, but it's floating on the DEM. Yep. What we see now is that our Grand Canyon looks more in 3D. It's better, right? Now we can do the same with our slope. Just define another color scale for the slope. Yeah, like this. We say it's floating on the DEM. So now you can really see that the red parts are the steepest parts of the Grand Canyon and the green are flatlands. Okay, what if we load the satellite image? the texture. And we do the same, right? Floating on a custom surface on the DEM is floating. Just wait a little till it's computed, and you can see a very nice 3D visualization of the Grand Canyon. Here what we can do is go to Rendering tab and to enhance it. So the quality will get better, and surprisingly, even the speed of the visualization will speed up. So here you can see very nice Grand Canyon in 3D. Pretty cool, right? Isn't it? Now we load the topographical map. You can see it's linked right under because there is no elevation data assigned to this map. So when we say it will be floating on our DEM, and we make the rendering the highest. And here you can see Grand Canyon as a topographical map. This is pretty cool as well. So you can see the contour lines, you can see here the National Park Information Center on all the roads, the buses are running around, and the Colorado River, which is blue. I think this is all an awesome visualization. Yeah, and now if you are satisfied with your data, you can create a video. Here somewhere, okay, if it's not here, we go right click in the gray area up here, and there should be animation tab. Okay, so here we go for the small camera. So you just define a keyframes which should be visible in your visualization, and at every point you want the camera to be positioned in, you just press the camera. Of course, there are more advanced way of visualizing these data using animation, but they are not part of this video. You can try to find them somewhere on the internet or S3 web page. Okay, so when I'm satisfied, I can go to this animation control. I can say that okay, my animation will last 15 seconds, and I go play. Now I can see how is my animation being played. Yeah, it's not a good one because I did it like in a rush. But anyway, it could be useful. So now you go animation, you go export animation, and then you got your data. Okay. So here, so far we have presented how to turn your point data into 3D model. We can do exactly the same. Just open a new document, and we open contour lines. Okay, so well, I'm back in ArcMap. I have loaded contour lines that I would like to convert into DEM. I will use the exact same process. I just go and check attribute table. Here is the elevation called Beachguide because these data are our local data. So, but you can see that here are elevation values. You always look for elevation values, not independently on the name of the field. Sorry, it's not in English. Well, we go to Toolbox. We find raster interpolation, topo to raster. We choose our layer contour lines. You see now that our contour lines. Here we define an elevation. We define output. Output cell size. Just to be fast, we set 20. Now we wait for interpolation to finish. And here we got elevation. So same process using points or contour lines. So now I would like to show you how to create a 3D model of any part of the world you desire. I will open a browser and I will go for Earth Explorer USGS.gov, like it's the site from USGS, United States Geological Survey, and here we can find elevation data or other interesting data for the whole world. So now we would like to check some nice place to visualize. Okay, let's say I like Zion National Park. So we try to search for Zion. Let's see what we find. So it's not Zion National Park. We try to find it. We got lucky. Okay. So Death Valley. So after some search, I found the Zion National Park right here. Zion National Park is a very nice place, so I would like to create a 3D model of it. So I will say that this is not actually my area of interest. I will just focus on this area of interest where the Zion is. Okay. Now we go to check datasets. So we have to look for the like there are many other datasets, but we go for radar and not the radar. Let me check. So we navigate to digital elevation, see SRTM and SRTM 1 arc second global. These data are covering the whole Earth or almost the whole Earth with a special resolution about 30 by 30 meters, which is pretty good because it covers all the world. Here you can check the coverage. So you can see that it's covering almost the whole world except the subpolar parts. So now we have checked our data. We have our area of interest defined here. Come on. So, now we can go for results, and you see that these two datasets are covering our area of interest. Here we can see the footstep of the data. So here or here. So it depends on, we can download both of the data, but just not to make it difficult, I will download these data. Here you may even see how the digital elevation looks like, right? And here is a button for download options. And what are our desired data is a GeoTIFF 1 arc second, 25 megabytes, but we have to log in. So here it just requires you to create your account, and now we can download these data. So we just wait till it downloads, and when it finishes, we open ArcMap, open new document, and we can try to load directly these data. SRTM. And here we get the data over Zion. This part is Zion. And what we have here, decimal degrees. And for the visualization, I propose to use the Web Mercator, because if we open the base map, it will be a little distorted. So we can use a function that is called project raster. Same thing we did with the vector data, now we do with the raster data. So this function loads, we open our diff file, it's in WGS, we say it will be Zion Web Mercator. Yep. Oh, it's too long, sorry. Yeah, output coordinate system is a Web Mercator. Yeah, we just get it transformed. So here we are, we just open the file again. So we are messing up with the coordinate systems. But here we have the Zion. Now you see we are in meters. We can open the base map, imagery. We just wait a little bit till it loads. When it loads, we can even try to compute a hill shade, shaded relief, right? So here you can check the Zion National Park in detail. Yeah, not much visible, quite a lot of shade in there, but doesn't matter. Anyway, we can work with this, I guess. We can work with this quite well. We just choose a part we would like to visualize. This looks interesting. So we go again, sorry, export map. Design texture. We start our scene. Come on. So now when it's loaded, so we open design texture. Here we go. We open design with Mercator. It's a DEM, right? See, yeah, both there. Just here we have this very small piece of our satellite image. And we say that is floating on the Zion Web Mercator, and when we see how it's gonna look like. Okay, we go back for the highest rendering. And here you see the Zion National Park. I think that is awesome, isn't it? And like this, you can visualize any place on Earth, in fact. Yeah, so that's it. Hope you did like it.